Hi team, it's Mr. Z, and today we're going to calculate the least common multiple, aka the common denominator of these, while also describing our restrictions. Let's take a closer look, shall we? Alright, in this first one, I'm going to show you using factored form, and it's essentially a way to show you how to do the more complex problems with just numbers. So when we're looking at this, we're looking at the denominators, and I see a denominator of 3 and 15, which are not the same. So what I'm going to do is I'm going to go ahead and rewrite the denominator as if it was x plus 1, and I'm going to write it as 3 times 5. Notice the number on the left is missing the 5, so I'm going to multiply 5 by x and 5 by 3. This is going to create an equivalent fraction, 5x over 15 plus x plus 1 all over 15. Now, the only reason I looked at it this way, you could have asked yourself, how many 3s do you need to get to 15? And the answer would be still 5. Now, I'm going to go ahead and combine them together. Now, I'm going to get 6x plus 1 over 15. Notice how there are no domain restrictions because there are no variables in the denominator. If I were to just describe the domain, all numbers work, meaning negative infinity to positive infinity with no gaps. Let's go ahead and take a look at another one. Remember, denominators, there are no domain restrictions. So the domain would be negative infinity to positive infinity. Now, I'm going to go ahead and represent this first one, 7x over 12 plus x minus 2 over 6. I am going to leave a gap plus x over 3. Now, I'm going to ask myself, how many 6 do I need to make 12? Because 3, 6, and 12 has a factor of 1 and 12, 2 and 6, 3 and 4. So I know both 6 and 3 go into it. 6 times 2, 3 times 4. It's important to note that this numerator, I am going to have to distribute the 2 to both parts. So when I'm rewriting it, 7x over 12 plus 2x minus 4 over 12 plus 4x over 12. Now I can just combine the numerators to create one big fraction. This is going to result in 13x's minus 4 over 12. All right, this next guy. Now this is a little more of a problem because I see that it's not in completely factored form. So before I do any thinking, I'm going to go ahead and rewrite the fraction in factored form. And it's going to be x times x plus 1. Now that it's in factored form, I can identify the domain restriction. X cannot be 0. X cannot be 0. X cannot be negative 1. So this is going to cause a restriction among the domain. If I look at it in terms of a number line, the number line goes from negative infinity to positive infinity, and it's going to have these gaps at 0, at negative 1. Thus, my domain is only going to be negative infinity to negative 1, negative 1 to 0, 0 to infinity. I'm just reading my number line going left to right to describe the 3 regions. Now, with that being said, I could get to the fun of finding a common denominator. So, what is missing in this. They both have an x. This one has an x plus 1. So what I'm going to do to this first fraction is I'm going to multiply it by an x plus 1 minus x minus 1 all over x times x plus 1. This is going to create, well, x plus 1 times x plus 1. I'm going to go ahead and multiply it out. It's going to be x squared plus 2x plus 1. You might want to use an area model if you need to. Minus x minus 1 all over x times x plus 1. Now be careful with the step. When you're subtracting it, you have to understand that I'm subtracting this whole fraction. This negative is going to be applied to both of these terms. So if you want to rewrite it as x squared plus 2x plus 1 over x times x plus 1, and then change it to a positive and distribute it to only the numerator, that is perfectly legal. This is essentially saying, hey, you got to distribute the negative kind of in the same way when we're doing long division. Now I'm going to combine like terms in the numerator. X squared, 2x minus x is 1x. 1 and 1 is 2. All over x times x plus 1. All right, one more. Now we got to factor this guy on site. Some of you might have to use your area model because it has a value, aka the front number is a little more complex. 2x squared, 6. Well, 2 times 1 is 2. X times x is x squared. And then I need to figure out a combination to get a middle number of 7x. So I'm thinking of the possibilities. I'm going to go ahead and put the 2 here and the 3 here. This is going to create the situation where I have 3x and 4x, and voila, I factored it. So rewriting in factored form is going to be, let me use x plus 2, 2x, what 3? Positive 3. Minus x over 2x plus 3. Let's look at my denominator. X cannot be negative 2. Now, this next one might be a little more complex. What is the x value? I don't see it immediately. Well, remember, we're asking ourselves the question, 2x plus 3 equals 0. When does this happen? And using inverse operations, you can find that x is going to be equal to negative 3 halves, negative 1.5. And then this is going to be the same value over here. X cannot be negative 1.5. So when I write out my domain, my x's go from negative infinity to positive infinity. I know that negative 2, and then I know that negative 1.5 is less that, so it's going to be closer to 0. I'm not going to include the 0 though because it's not actually a restriction. And then I'm going to write out my domain. My domain for this guy is going to be left to right, negative infinity to negative 2, union negative 2 to negative 1.5. I'm going to actually write it as a fraction. Union negative 3 halves, comma, infinity. With that being said, now I can go around and get to the business of finding a common denominator. So I see that 2x plus 3 is similar. I see that x plus 2 is missing from this right term. So I'm actually going to just rewrite this guy on the left, exactly as is. I already did the work of factoring it. Minus x over 2x plus 3. And I'm going to multiply both of them by x plus 2. This is going to create the same minus, let me distribute the x into both parts. X times x is x squared. X times 2 is positive 2x. And then it's going to be, I'm going to put a parentheses around it. So you can see how I found the common denominator. I need to make sure I distribute this negative to both pieces when I'm combining them. I like to write it out again. And even though it seems like a pain, just by rewriting the left, we know it is all good to go. So we're going to go ahead and think of it as minus x squared minus 2x all over x plus 2 times 2x plus 3. It's legal. If I multiply, I can switch the order. 3 times 2 is the same as 2 times 3. That's why essentially what I did here was switch the order. I did it just to be consistent with my fraction on the left. Let me combine these two guys together. This is going to result in negative x squared. A positive x and negative 2x is negative 1x minus 3 all over x plus 2 times 2x plus 3. Now, I can go ahead and try to factor this out a little further. I could factor out a negative 1. A negative 1 from the top is going to produce a positive x squared, a positive x, and a positive 3. X plus 2 times 2x plus 3. And I kind of look at this and I say, well, I can't really factor the top, so I'm just going to go with this domain restriction. Hope this helped, team. That's it for now. Ciao.